show two phases of good jet aircraft operation, ground procedures, and normal flight procedures. Ground procedures will be shown for pre-flight and after-flight. When you have checked the Navy yellow sheet form for the status and maintenance certification of the aircraft and know that it has been serviced for the mission, proceed as you would with any other jet aircraft to make sure that it is clean, shipshape, and secure, ready and safe for you to fly. Here are a few special points of inspection on the F4D-1. Check that the landing gear down lock pins are in place. Be sure the oleo strut has the proper spacing. Check to see that there are no cuts on the tire and that the slippage marks are in proper alignment. A thorough inspection of the exterior will take you completely around the aircraft. As you proceed around the starboard wing, check the slat for free movement. At the wing fold joint, the elevon accumulator gauge should read 1,000, plus or minus 100 psi. Check the outboard elevon for damage. The tail bumper air gauge should read about 225 psi, and the arresting hook gauge should show from 475 to 500 psi. Inspect the afterburner movable parts to make sure that none are loose. When you are sure the exterior is clean, undamaged, and safe for flight, you are ready to go topside. Before you sit down, remove the safety pin in the canopy remover initiator. No matter what other naval aircraft you have been flying, you will find a familiar cockpit layout, with flight instruments grouped on the main instrument panel. On consoles to the left and right of the pilot, the control switches, oxygen, and communication equipment are mounted conventionally. There's no waste space in this cockpit, so when you are connected up and fastened down, take time to make yourself comfortable. Make sure the engine master switch is off. Then use external power or the aircraft battery to adjust the seat and rudder pedals. For the cockpit check, you may work out your own procedure or follow your squadron practice. Here are the special cockpit checks for the Skyray. See that the mechanical advantage changer crank is in the stowed position and that the indicator shows takeoff and land. Check that the pitch trimmer circuit breaker is on, yaw damper and autopilot switch on, and fuel system selector switch normal. Drop tank switch off. Test all push-to-test lights. When you are ready to start the engine, check that both the external electrical source and air compressor starting unit are connected and operating properly, with fire guards standing by. The access ladder should be away. Turn the battery generator switch on, and both generator switches on. Make sure the AC generator field switch is at guarded on. Let's watch a normal start. Turn the master engine switch on and depress the starter button. When the tachometer indicates 12 to 16% RPM, push the power control lever outboard momentarily to ignite. Then move it to idle. Ignition will normally occur within 20 seconds after the power control lever is moved to idle, and then the engine should accelerate to 56 to 63% RPM. At idle RPM, the oil pressure should read between 40 to 50 psi. Tailpipe temperature should not exceed 630 degrees centigrade during acceleration. If tailpipe temperature exceeds 630 degrees during the start, shut down by moving power control lever to off and master engine switch to off. Shut down if the engine fails to ignite within 20 seconds after the power control lever is moved to the idle position. Shut down if the engine starts but refuses to accelerate to idle RPM. With any bad start, investigate the trouble. Before attempting another start, let the starter cool for 3 minutes. Then purge the engine by turning the master engine switch to off, with power control lever off. Depress the starter switch and crank for 10 to 20 seconds. Pull starter switch up to stop the cranking cycle. With ground connections away, let's make the run-up. Both generator warning lights are off. Normal fuel boost pressure shows that there is AC current available to run the pumps. Check the hydraulic systems. First, unfold the wings, then operate the elevons for smooth, rapid response. If the pitch trimmers are operating, we know there is DC available. Also, check pressure at the flip-flop indicators on the main instrument panel. Check fuel quantity gauge operation with the test button. Bearing in mind that the canopy will shear off when open if wind components reach 60 knots, it's a good idea to taxi with the canopy closed. If maneuvering on the ground is kept at a minimum, more of the fuel you carry can be used for flight reserve. Once in motion on hard, flat surfaces, the airplane will roll with the engine idling. Visibility from the cockpit is very good. If the taxi strip is clear, let the airplane roll freely, using the brakes for steering only. At the head of the runway, you will make your pre-takeoff checks. Make sure the area behind is clear so no damage will be done by engine blasts. Also be sure to allow room ahead because the aircraft will slide on locked wheels at high power settings. With the engine idling and fuel system selector switch in normal, check the following readings. Tachometer 56 to 63% RPM. Tailpipe temperature 360 degrees centigrade maximum. Oil pressure 40 to 50 psi. 30 psi minimum. Fuel pressure 30 to 50 psi. Fuel failure warning light not glowing. Then switch the fuel system selector switch to manual and advance the power control lever toward military. If the TAC exceeds 80%, consider the manual position check a success. Keep the tailpipe temperature within acceleration limits. It should not exceed 630 degrees centigrade. Return the power control lever to idle and the fuel system selector switch to normal after TAC drops below 70%. Meanwhile, cover your takeoff checklist using the placard in the aircraft. Pitch trimmers 3 to 4 units up. Rudder trim 0. Lateral trim neutral as indicated by stick position. Brakes set. Advance the power control lever to takeoff position with afterburner if desired. Release brakes before reaching military RPM or igniting afterburner. If all instrument readings are within operating limits, continue the takeoff run. Use brakes and rudder to maintain directional control during the first part of the takeoff. As the rudders become effective above 50 knots, steer by rudder alone. Keep the nose wheel on the ground. At about 125 knots, a little back pressure on the stick will lift the aircraft gently off the ground. As soon as you are airborne, retract the landing gear and lower the nose slightly to pick up best climb speed. Accelerate as soon as possible to best climbing airspeed. A good rule of thumb for maximum afterburner climb is fly at 0.9 Mach, or just under the trim change, all the way to combat ceiling. In this speed range, small changes will require retrimming. The flight characteristics of the aircraft are good at subsonic and supersonic speeds, and acceptable at transonic speeds. Stick and rudder coordination are normal. The Skyray must be flown at all times when the flight stabilization system is not fully engaged. At all flight speeds and altitudes, the mechanical advantage changer system makes for smooth flying. Stalls are preceded by buffeting and yaw, 10 or 15 knots above stall speed. The rate of descent is about 4,000 feet per minute. As speed drops, the yaw develops rapidly and should be controlled with the rudder, or a spin will result. At the stall, the nose drops sharply. Recovery is normal. Accelerated stalls are similar to normal stalls except for airspeed. The Skyray's high-speed flight behavior is excellent. Beyond 0.89 indicated Mach number, there is a nose-down pitch, which disappears when sonic speed is attained. These effects are heavy and can be dangerous at low altitudes. At supersonic speeds, control effectiveness is adequate, although control of pitch trim is reduced and the rate of roll tends to be very high. Speed brakes are effective and can be opened at any speed. There is some buffeting, and brakes tend to blow back at speeds above about 450 knots. A vertical dive at military power will result in maximum speed of approximately Mach 1.1 between 35,000 to 30,000 feet. Bear in mind that recovery may cost as much as 20,000 feet of altitude. Allowable maneuvers are defined in the latest revision of the pilot's handbook. Be guided by the maximum permissible Gs according to weight, airspeed, and altitude. At high speeds, the elevons can give rates of roll which overstress the aircraft. Inverted flight is limited to 10 seconds maximum. The approach letdown can be made at any desired speed with engine in idle and speed brakes extended. In the pattern, run through the landing checklist. Adjust trim and make sure pitch trimmers are working properly. Master armament switch off. Lock the shoulder harness. Now let's look at the overall landing approach. Enter the pattern as required by local flight rules and slow down with the speed brakes. Below 180 knots, lower the landing gear. If partial power is desirable, use speed brakes to control approach speeds at about 140 knots in the base leg and final turn. When the runway is within reach, slow down to 130 knots and flare out to land when quite close to the ground. It is not advisable to change speed brake position in the final approach due to the associated trim change. Plan your pattern so that you do not establish a high rate of sink near the ground. Let's follow through. On downwind leg at about 170 knots. Landing gear down and locked. Make the turn into the field at 140 knots. The runway is in reach now, so slow to 130 knots until ready to flare out for the landing. The very high angle of attack landing attitude usually lets the tail bumper touch down first. With plenty of runway, hold the nose up to get drag for slowing down. Steer with the rudder. On short runways, let the nose down and use brakes. When rudder control fades at about 60 knots, apply the brakes as necessary to control the landing run. In the event of a wave-off or incomplete landing attempt, apply military or maximum power as required. Retract the landing gear immediately. Trim nose down to pick up speed and fly clean until ready to attempt another landing. Let's watch one more landing for some important pointers. The F4D-1 handles like any other jet aircraft, except that at low speeds, the sink rate is very high. Also, at low speeds, lateral stick movements cause an adverse yaw tendency, which should be countered with rudder. Lateral stick forces are high. The yaw damper and the pitch trimmers are very helpful at low speeds. Use them. Bear in mind that at speeds approaching a stall, even full power application may not stop the aircraft from settling. Because of visibility reasons, the aircraft is landed above its stalling speed. Touchdown is at about 110 knots with 1,000 pounds of fuel aboard, and the stall is at about 103 knots. Landing with the canopy closed may seem strange at first, but you will find that it has advantages in more positive opening, safer ejection, protection from noise, wind, and carrier smoke, and protection from barricade straps. In securing the aircraft after flight, idle the engine for 5 minutes before shutdown to cool it and to drain the afterburner fuel lines. Meanwhile, secure the miscellaneous controls, switches, and instruments. Double-check that armament switches are off or safe. Be sure fire guards are posted. Then set power control lever to off, master engine switch to off, and pitot and engine anti-icing off, and engage the rudder gust lock. Check that the engine decelerates freely with no unusual noise. Finally, turn all electrical power switches off. In this film, you have seen some of the procedures in handling the Skyray on the ground and in the air. More detailed study of your flight handbook will help you perfect your understanding of this excellent Navy interceptor.